75 or 25%. Again, these have to add to 1, so we're getting 25% absorbed and 75% transmitted. So that's the way we work out these problems, that we always have the incoming light, and then we have to find out what are the components with respect to the bases that we're using in the filter. The filter has a predetermined set of bases that it is using to do the measurement, that they have to be aligned with the transmission axis of the filter. Now, let us say that this is filter 1, this is filter 2. Oh yes, and when it comes through the filter, then it's going to be in a pure state. The pure state is going to be the transmission state. The 75% of the light is going to all be in this state. That's the vector that represents the light coming through the filter. It has an orientation, a polarization at a certain angle. Okay, so now let us see what happens if we go to a filter that is crossed with the very first filter. So we've got a vertical filter first, then we have a filter inclined at 30 degrees, and then we're going to have another filter that's going to be horizontal, selecting for horizontal light. So that filter be filter 3, and that one will have a couple of vectors that look like this. So it is transmitting horizontal light and absorbing vertical light. And we are having light, a pure state of light in this state coming to interact with the filter. In other words, I should write it up here. The light is going to be square root of 3 over 2 minus 1/2. And that is hitting this filter. So now we have to do the same process again. We have to find out for our light, square root of 3 over 2 minus 1/2. We then have to project it onto the bases, onto the axes of our filter. The filter is looking for horizontally polarized light to transmit, and is looking for 1, 0 vertically polarized light to absorb, and we have to figure out these two coefficients. And again, it's the dot product of our incoming light with the two vectors of the filter. So these are both unit vectors. They have a length of 1, so we don't have to worry about the lengths of the vectors. We can just take the dot product. So it's square root of 3 over 2 times 0 plus minus 1/2 times 1, and so that's going to be minus 1/2. And then over here, it's going to be square root of 3 over 2 times 1 plus minus 1/2 times 0, so that's going to be square root of 3 over 2. And that tells us that we're going to have minus 1/2 squared equals 1/4, or 25%, coming through as a result of this whole chain of different filters, and that this one is going to be square root of 3 over 2 squared. It's going to be 3 over 4 equals 75%. So how much got through all the way? Well, in the first case, for the first filter, it was basically 50%, or 1/2. In the second filter, it was 75%, and in the third filter it was 25%. So if we go 1/2 times 3/4 times 1/4, we will get 3 30 seconds. 3 30 seconds.